So this video is about solving equations, specifically linear inequalities. We are going to talk about how to solve those and what approaches to take. We're also going to talk about graphing these on a number line. So the solution set for an inequality is a little bit different, and we're going to talk about what that looks like and how to show that or graph it to show the solution set. So the first thing we need to know is about inequalities themselves. A linear inequality can be written in a couple of different ways. Now notice these are all exactly the same except for the inequality signs. So you have a less than, you have a greater than, you have a less than or equal to, and a greater than or equal to. Otherwise, they look exactly like a linear equation. And the nice thing is you solve them the same way. The only difference is that the solution to an inequality is some value that makes it true when you plug it in. And because there's more than one value that can make it true, we talk about a solution set versus just a solution. So we're not going to get a solution where x is equal to 5. We're going to get a solution where x is every number greater than 5 or less than 5 or whatever. That's why we graph it on a number line. And so when graphing on a number line, we need to talk about when to use a closed circle versus when to use an open circle. A closed circle is used when there's the equal to under it. An open circle is when there's no equal to. This is just like the graphing with the linear inequalities, the same rules apply. So let's start with just graphing this on a number line. Now, the number line is kind of fun because you can label it however you want to, dependent on the numbers that you have. So for this one, because I'm only talking about 2, I'm going to put 0 in the middle, and I'm going to go 1, 2, 3, and then I'm going to go 1, 2, 3 to the other side, and then I'm going to make a point at 2. Which is right here, but because of the symbol not having the equal to part, I'm going to make an open circle. And then this is talking about x is less than 2, so I want all of the numbers that are less than 2. Well, that's 1, 0, -1, etc., all the way to the left of 2, so I'm going to draw an arrow, to symbolize that I'm looking at all of the numbers that are less than 2. Let's try another one. So we're going to graph x is greater than or equal to 1. Again, my number line is just blank. I'm going to fill in my own numbers. This time I don't even need as many. And where x is greater than or equal to 1, I'm going to make a closed circle this time. Now, how did I know it was supposed to be a closed circle? Because it has that equal to underneath. Then this statement is telling me that x is greater than or equal to 1. So I'm looking for all the numbers that are greater than or equal to 1. Well, that's 1 and 2 and 3 and 4. All the way up, so I'm going to draw my arrow to the right to show that I'm including all the numbers 1 and larger that in my solution set. Now let's talk about solving a linear inequality. You solve it exactly like you would an equation. You undo each side, so you add to undo subtraction, et cetera, et cetera, et cetera. And then when you get to the end, instead of having x equals a number, you will have x is greater than a number, or x is less than or equal to a number, okay? So you'll just have an inequality sign, and then the solution set can be graphed on a number line. Now there's one thing you have to remember, and this is the most important piece here. If you are multiplying or dividing by a negative, the inequality sign has to be flipped. So for example, just to give you one, let's say you have negative 5x is less than 25. You're going to divide by negative 5, which means that you have x and you have negative 5, but instead of being less than, you're going to flip the direction of the inequality and make it x is greater than negative 5, okay? And we'll talk about that a little bit more. So let's try a problem. We're going to solve this linear inequality. Now I'm going to pretend it's just like an equation, which means I want to get the x's on one side and the constants on the other. So I'm going to start by subtracting the 5x. And then I'm going to add the 4. So I have 6 is greater than 2x. I'm going to divide by 2, and I get 3 is greater than x, which means that x is less than 3. I'm going to graph my solution set on a number line. If I can get it to graph here. I'm going to go 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I want x is less than 3, which means I have an open circle at 3. And I'm going to cover all the numbers less than, which means I'm drawing my graph to the left. Okay? So we're solving the inequality just like we would an equation, but then we're graphing that solution set to show that we're including all of the values less than 3. Let's try this next one. So we're going to solve this one. Again, I want to get the x's on one side and the constants on the other. So I'm going to start by subtracting the 5x, which just gives me x is greater than or equal to -7. And I'm going to rewrite this so that it's in the right order. I would like my variable to be first. And then I'm going to graph on a number line. So this time I need -7. So I'm going to actually put 0 here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go to -9. I was going to try to get to -10. And then at -7, we're going to make a closed circle. Now, how do I know it's a closed circle again? Because it's got the equal to underneath the inequality. So it's greater than or equal to, I'm going to use a closed circle. And it's greater than, which means I want to go to the right because I'm going to cover all of the numbers that are greater than -7, -6, -5, up to 0, and then 1, 2, 3, etc. Okay? So we're solving like an equation, and then we are graphing on a number line. Let's try a couple more. This one's pretty easy to solve. We just have to divide by the -0.25, and 2 divided by -0.25 is -8. If you don't believe me, check that on your calculator. But then because we're dividing by a negative, we're going to flip the direction of the sign. So instead of y is greater than, it becomes y is less than or equal to -8. We're going to graph this on a number line. And again, I think I'm going to start over here at 0, and I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to -10. And I'm going to put a closed circle at -8. Again, how do I know that it's closed? The line underneath the equal to part tells me that's closed, and I'm going to point my arrow to the left because we're looking at all of the numbers that are less than -8, which is -9 and -10 and -11, more negative. All right, go ahead and pause the video. Try this last one on your own, see how you do, and then unpause it and check, okay? So there's a couple different ways that you could have done this. I'm going to start out by distributing the 2. Just because I want to get rid of those parentheses. Hopefully when you distribute, you're remembering that it's 2 times x and it's 2 times 6. Now I'm going to get my x's to one side, so I'm actually going to subtract this 2x over to the other side, and then I'm going to subtract the 9. Which means that I'm dividing by -7, so I'm going to flip my sign, and I have x is greater than or equal to +3. So it was less than or equal to, but because I'm dividing by the -7, I'm going to flip the sign. Think about it. If you're changing the sign of the variable, like on this last one, this was a -y and it becomes a positive, we're flipping the sign, the inequality. Same with the x. It was a -7x, now it's a positive, flip the sign. The last thing is to draw it on the number line, and I'm actually going to do it on top of the problem so I have a little more room here. And I need 3, so I'm going to put 0 in the middle and go 1, 2, 3, 4. 1, 2, 3, 4 to the left. And then I'm going to make a closed circle at 3. Am I going to the right or the left? Well, we're talking about greater than, so we're going to go to the right. Hopefully you're feeling pretty confident about solving inequalities as well as graphing them on the number line and being able to show the solution set. Best of luck with all of your inequality solving.